Hello everyone and welcome back. So this time we're going to be jumping into absolute temperature scales. So let's get to it. And I am blocking up. I'll stick myself in this cloud right here, a cloud of Dr. Kidd. Okay, so in the absolute scales we have Rankine and Kelvin. Rankine is to Fahrenheit what Celsius is to Kelvin. So Rankine and Kelvin are absolute scales. That means that 0 is as low as you can go. And it also means that 0 Rankine is the same thing as 0 Kelvin. There's the same point. It's like 0 meters is the same thing as 0 inches, which is the same thing as 0 feet. They all start at 0. Rankine is the same size as Fahrenheit, so the steps are the same. And to convert between the two, you'll see that next time. Kelvin and Celsius, same size as Celsius step. Kelvin has the same size step. It just starts at 0 instead of starting at where water freezes. Now, when you're trying to convert between Kelvin and Rankine, because they are absolute scales, you can use a conversion factor where 1 Kelvin is equal to 1.8 Rankine. Okay, now I'm using this absolute scale. Like, how do we determine what this is? Did somebody just like, put something in a fridge and just keep on cooling it down? Well, that's as low as it goes, so I guess that's absolute 0. Well, it's all based on something you haven't quite learned yet. We'll get there, but we're not there yet. It's that PV equals nRT. This is saying that pressure and volume of a gas are connected to the number of moles of the gas times the temperature, with a little proportionality constant in there. That's just a constant, it doesn't change. And so they said, okay, well, if I know what the volume of a gas is at a particular pressure, just, set pressure, don't change anything else. And I keep on decreasing the temperature, that would say that, volume and temperature should be proportional. So if the temperature keeps on going down, eventually my volume should go to 0. Now, do we actually do that? No, we don't. And technically an ideal gas would, liquefy and then solidify at some point, except for helium. Helium actually never turns solid. It's always a liquid, even if you cool down. And so where we get the idea of absolute 0 is the point where an ideal gas would have 0 volume. That can't happen, and so that has to be the lowest temperature. Now, who knows? Maybe in the future we'll find out that it's slightly less or more than we think absolute 0 actually is. But we've gotten things really cold before, like 2, 1 Kelvin. It's, right above absolute 0. So it's definitely not more than that, but it could be a little bit less. Like there could be a lower point that we're just not understanding yet. For this class, they're not required to know about the ideal gas law yet. But the big thing is just remember that Kelvin and Rankine are those absolute scales. They start at 0 temperature, and you can use a conversion factor instead of an equation to convert between them. As for how you get to Rankine and Celsius, well, we'll talk about, Rankine to Fahrenheit and Kelvin to Celsius. We'll talk about that next time. So I hope this helped you, and I'll see all of you later. Bye-bye.